Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be looking at some applications of quadratic formula which involve projectile motion. Now, when an object is thrown or launched or dropped, the path of the object will follow a parabolic path as shown in this image. It'll be launched or dropped from an initial height. It'll reach a maximum height, and then after a certain amount of time, it'll hit the ground or have a final height. Now, there's a couple things that we need to keep in mind when we're dealing with projectile motion problems. The first thing is, what is the particular question asking us for? Because sometimes it'll ask, what was the maximum height of the object? The next question might say, from what height was the object dropped or launched? Or it might say, how long does it take the object to hit the ground? So for each one of those, we use a different part of the path of the object. So the initial height would be found at the y-intercept or the point 0, c. The y-intercept or the point 0, c. The maximum height of the object will be found at the vertex of the parabola. And remember, to find the vertex of a parabola, we use the formula opposite b divided by 2 times a, and then f of opposite b over 2 times a. The time it takes to hit the ground, that is the 0 of the function, and we must use the quadratic formula to find that 0. So let me just review the formula for you for quadratic formula. X equals opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So depending on what the particular question is asking, that'll depend on which formula you're using to find your answer. So let's look at example 1. An object is launched directly upward at 64 feet per second from a platform. The equation for the object's height, h, in feet, at time t seconds after launch is h of t equals negative 16t squared plus 64t plus 80. So what's happening here? Let me kind of draw it. We just need a first quadrant graph because time is positive and height is positive. So we have the time is being plotted on the x-axis, and they're calling that t. And then the height of the object is being plotted on the y-axis, and it's starting up here. It says it's starting up here somewhere. It doesn't tell us where. It's going to reach a maximum height, and then finally it'll hit the ground somewhere over here. So there's 3 important parts here. Where was it launched from? What was its maximum height? And how long will it take to hit the ground? So the first question says, what was the initial height of the object? Well, remember, the initial height of the object is the y-intercept, or it's the point 0c. So what we want to do is look at our equation here. Let me highlight. We have h of t equals negative 16t squared plus 64t plus 80. Well, our c value here is 80. So that's telling us that the initial height of the object was 80 feet. So I'm just going to label that with an 80 right there. So there's your initial height, 80 feet. All right. Next question is, how long did it take the object to reach its maximum height? And what was the maximum height? So the maximum height, remember from our box above, is found at the vertex. So let's calculate our vertex here. So our vertex is x equals opposite of b divided by 2 times a. So in this problem, b is 64, so we're taking opposite of 64 divided by 2 times a, which is negative 16. Now, if I put this in my calculator, press the division bar to make a fraction, negative 64 over 2 parenthesis negative 16, and that gives me 2. So I know my vertex is going to be 2 comma something. All right, now to find the maximum height, you're going to find h. Whoops, I didn't want to write t. H of 2. We want to evaluate this function for 8 at 2 seconds. So h of 2 would equal negative 16 parenthesis 2 squared plus 64 parenthesis 2 plus 80. Now when I put that in my calculator, negative 16 parenthesis 2 parenthesis squared plus 64 parenthesis 2 plus 80, we get 144. So what that tells us is when the time is 2 seconds, the height of the object is 144 feet. Now, let's answer the question in a complete sentence. How long did it take to reach the maximum height? What was the maximum height? So it took 2 seconds to reach a maximum height of 144 feet. It took 2 seconds to reach a maximum height of 144 feet. All right, problem C. How many seconds will it take to hit the ground? So in our box up here, the time it takes to hit the ground is the 0 of the function, and we need to use the quadratic formula. So to use the quadratic formula, we need to identify our A, which is negative 16, our B, which is 64, and our C, which is 80. And then we'll plug all that into the quadratic formula. So x equals opposite of B, which is 64, plus or minus the square root of B squared, or 64 squared, minus 4 times A, which is negative 16, times C, which is 80. Let me extend that square root. All over 2 times A, which is negative 16. All right, so I'm going to come over here. I'm going to press the division button, and I'm going to type in negative 64, and I'm going to use plus square root, parenthesis, 64, parenthesis, squared, minus 4, parenthesis, negative 16, parenthesis, 80, over 2, parenthesis, negative 16. All right, my first solution is negative 1. Now I need to find my second solution, so I'm going to go back up here and change this plus to a minus, and I get x equals 5. Now, when we're talking about time, time cannot be negative, so I'm going to mark out that answer, and I'm going to say it took 5 seconds for the object to hit the ground. Now I'm going to come up here and label my graph. So this happened at 5 seconds. All right, next question. What was the height of the object at 1.5 seconds? So this is telling me my x value is 1.5. So we're going to evaluate this function at f. Well, I'm sorry, the function name was h, wasn't it? We're going to evaluate this function at h of 1.5. So we'd say negative 16 times 1.5 squared plus 64 times 1.5 plus 80. And then you'll just put that in your calculator. Negative 16 parenthesis 1.5 parentheses squared plus 64 parentheses 1.5 parentheses plus 80, and that gives us a height of 152 feet. Now, for the domain of the function, these are our x values. So we're talking about time. So our beginning time is going to be 0 seconds because we can't have negative numbers. And our ending time, in other words, what time did the object hit the ground? Well, it hit at 5 seconds. So I'm going to say 0 to 5, dealing with time, and then surround it by less than or equal to symbols. So the time of the function is 0 to 5 seconds. Now, the range is the height of the object. So our lowest height was 0 when it hit the ground, and our tallest height was 144. So I'm going to put 0 on one side, 144 on the right side. Our variable is h of t, and then less than equal to, less than equal to. All right, example 2. Jack was so frustrated with his slow laptop that he threw it out of his 10th story window. The height in feet of the laptop at time t seconds can be modeled by the function h of t equals negative 16t squared plus 28t plus 212. So here's what's happening in this problem. We're again going to have time on the x-axis and height on the y-axis. He's up here in the 10th story building, so way up tall. He throws his laptop out, and then it goes down, down, down till it hits the ground. So again, we're concerned about where it started, what was the maximum height, how long did it take to hit the ground. So remember, the initial height comes from the y-intercept or the point 0c. So all you do is you look at your a, b, and c. So our formula is negative 16t squared plus 28t plus 212. So our initial height was 212 feet. So I'm going to put that right there, 212. Okay. What was the maximum height of the ball? Well, remember, maximum height comes excuse me, from the vertex. And to find the vertex, we use this formula. Okay, opposite b over 2a, comma, f of opposite b over 2a. So x will equal the opposite of b, which in this case was 28, over 2 times a, which was negative 16. Now let's put that in our calculator. And that gives me, let's see, negative 28 over negative 32. So 0.875. I'm not going to round it right now. So that means my vertex is happening at 0.875 seconds. And we don't know the maximum height yet. So to find that, we're going to evaluate the function for h of 0.875. So to do that, we'll take negative 16, parentheses, 0.875, parentheses squared, plus 28, parentheses, 0.875, plus 212. All right, now we'll evaluate that on our calculator. Negative 16, parentheses, 0.875, parentheses squared, plus 28, parentheses, 0.875 plus 212, and that gives me 224.25 feet. So there is the maximum height, 224.25 feet. So the maximum height of the laptop was approximately 224 feet. Next question, how many seconds will it take to hit the ground? So it's going to hit the ground right here. And to find that, we'll have to find the zero of the function because it's an x-intercept. So we're going to use our quadratic formula. So we'll take opposite of b, which would be opposite of 28, plus or minus the square root of 28 squared minus 4 times a, which was negative 16, times c, which was 212, all over, make sure that fraction bar covers everything, 2 times a, or negative 16. All right, so I'm going to push my fraction bar here on my calculator. Negative 28 plus square root, parenthesis 28, parenthesis squared, minus 4, parenthesis, negative 16, close parenthesis, parenthesis, 212, all over negative 32. Whoops. Negative 32. All right, now that gives me a negative number, and I know seconds can't be negative, so I'm going to come up here and change this plus to a minus. And that gives me 4.6187 seconds, and it says to round to the nearest hundred, so 4.62 seconds. So it will take 4.62 seconds to hit the ground. All right, so for the domain, remember, is the time. Our lowest time was 0, and it hit the ground at 4.62 seconds. The range is the height of the laptop. So it hit the ground at 0, that was its lowest height, and its maximum height was 224.25 feet. So let me label this domain and range. And that concludes today's lesson, applications of quadratic formula.